The two projects are the top project, the tagging of Pacific predators, which uses satellite technology. The satellites were already in the sky. The animals carried relatively large tags that could carry information up to the satellites. The second project is called the Post-Pacific Ocean Shelf Tracking Project, and it uses acoustic tags that talk to that can travel in very small animals, but you have to put out a chain of listening stations along the bottom of the sea. So we had to create a whole new way of communicating under the ocean for the POST system. Just to give you an idea of why we needed two systems, this is the size of the animals, pelagic animals in the ocean, and the major groups, and only about 10% of the diversity of organisms in the sea are capable of carrying the tags that talk to satellites. But 75% are capable of carrying the acoustic tags, so that if you want to understand the ecosystem and to manage the ecosystem, you need to have both of these technologies and have them working together. Now, here's some of the output from the satellite program. You can see some 23 different species were tracked all over, primarily the North Pacific. There is a few South Pacific species and a few, mainly the leatherback turtles that you just popped up there off the coast of Chile. George Schillinger will tell you a little more about those this afternoon, I believe. Of course, Barbara Bloch's favorites are the bluefin tuna. This is the track of the Genevieve, the turtle that won the first great turtle race in 2007. And you'll notice down here that she did in fact come into the EZ of Chile. So you did get some attention from the tracking program. Now, what do we need to know about these animals for, the distribution of these animals? These are loggerhead turtles, and you can see that a large amount of information about the loggerheads shows you that they are very responsive to the temperature regimes, and they move back and forth with those temperature regimes. I'm going to talk to you briefly about a longline fishery off Hawaii, and you can see that in some seasons these turtles are very prevalent off Hawaii, and in other seasons they're very far away. That gave rise to a very exciting compromise. This is a voluntary closure of the longline fishery off Hawaii, and it's an optimization problem. By reducing the income of the fishing companies by 10%, or less than 10%, there was a decrease of over 50% in the number of turtles that were caught. Now, these turtles aren't just caught, they have to be released again, and it takes a lot of time, and so the fishermen were very pleased to come up with this solution and instituted it voluntarily. So it's a great way of thinking about how to manage an ocean. In addition to telling us about their own needs and preferences and locations and travels and routes, these animals turned out to be great oceanographers, and these are the tracks of elephant seals off from California, out all over the North Pacific, and they are diving to 2,000 meters several times a day, and they're returning more oceanographic information that modelers can use than the Argo float system, which is part of the Goose network. So the animals can not only tell us about their own needs, but they can tell us about things that we need to know to understand what's happening in the oceans. The POST system just has the primary interest of the POST system was in salmon, commercially important salmon from the Columbia River for the most part, but other groups as well. And a complete surprise here is the green sturgeon. These green sturgeon were actually being tagged in California in the river systems where they are endangered. And it turned out that they actually spend half of their lives in Canada off Vancouver Island. And in Canada, they are subject to a fishery. Not a directed fishery, but they get caught by accident. Now here's just a movie showing you some of the things moving around, a lot going on. You can see all of these different species of salmonids of one sort or another. And the purple over here, those are the green sturgeon that came up from California. The good news is that as a result of this data, Canada has closed the fishery during critical moments off the island, and so this endangered species is protected in both countries. The largest single contribution of the POST project, I think, is in relation to the dams on the Columbia River. I'm not going to explain everything here, but by tagging these fish, the POST project was able to show that the collapse of the salmon populations in the Columbia was not the result of things that were happening in the river, but rather it was a result of things that were happening in the ocean. And those the changes in climate and timing of events in the ocean were suppressing or irregularizing the characteristics of these salmon stocks. And this was good news for the people in charge of the Columbia River Dam system, because there was a time when they were talking about spending $3 trillion taking all of the dams out of the Columbia River, and as a result of the evidence, or in part as a result of the evidence from POST, it became clear that this was not going to solve the problem. Another example, the POST system really created a gigantic laboratory in the sea. And this is some work done by a PhD student who's now a postdoc in Norway. She tagged both wild stock salmon and hatchery-reared salmon. And what you see is that the wild stock salmon actually know where they're going. And they are going out to sea rather rapidly, while the hatchery-reared salmon just sort of mill around inside the Salish Sea. And in the end, almost 10 times as many wild fish got out to sea to complete their life cycle as hatchery-reared fish. So what this means is that with this giant experimental system, we can actually improve the genetics, we can improve the characteristics, we can make better hatchery-reared fish. They spend over $100 million a year on hatchery-reared fish in British Columbia, and most of them never go anywhere. Now I'm going to talk about another species here that we've tracked that has links to Chile. The Dosidicus gigas, the Humboldt squid, originally was primarily fished off Chile and Peru, and then in about 1970 it established a new area of breeding in the Sea of Cortez in Mexico, and since then it has actually invaded Alaska. So this animal has increased its range all the way from Chile to Alaska, and at the same time it also has moved further and further south. So this is a very flexible species, a very adaptable species. There are several different things. The oxygen minimum layer has been changing, the temperature structure of the ocean has been changing, but also the predator field that this animal has to interact with has been changing. The decreasing size of fishes in the ocean means that there's not very many things left that can eat a 40-kilogram squid, which is what these things get to as adults. So it's a very interesting story and still unresolved, but we're gathering more information. This is a Humboldt squid being eaten by a black bear in Alaska. And the POST system has recently tagged Humboldt squid in Washington State in the US and observed them making their southward migration to breed. They breed in warm water, but they invade the cold water for food. So we're starting to get a picture of how this system works. Now, the concepts of bringing together post and top and integrating these technologies led us to propose something called the Ocean Tracking Network, which is a part of Goose, as Jesse described. And what this system does is it puts a series of receivers across the bottom of the continental shelf or other locations, and it monitors fish that go north and south, but it also collects physical data about what's going on at the bottom of the sea. So it is in fact providing a unique kind of physical data that you can't get from satellites, and at the same time it's monitoring the movements of the animals in a way that allows us to understand how those animal movements change as the climate changes. The core of the Ocean Tracking Network is from Canada. We have funding from the Canadian government that contributes to our partnerships all over the world. The first map showed you that we have partnerships all over the world. It's not just in one location. And so the POST system continues to grow on the west coast of Canada. We are extensively increasing areas of activity on the east coast, and we're starting to move into the Arctic, as well as these global partnerships. Some of the goals of the system are to improve the technology and provide better integration. One of the approaches that we're using is here in the Venus-Neptune cable systems. These are large cable systems that go hundreds of kilometers offshore. We've tested the system here so that it's now possible to feed that data back on the cable from our receiver systems that are detecting fish. And we're working on what's called daisy chaining that will allow individual receivers to talk to each other and send the information back so that you don't have to go out and harvest it with a ship, but rather can get it back automatically. On the East Coast, our primary site is what's called the Halifax Line. It's an area that has been surveyed for 60 years using oceanographic techniques. But unfortunately, when you use a ship to go out and collect information about water column characteristics, it's asynchronous, and so you can't really correct for tidal effects. And the modelers are very keen on having this instantaneous or simultaneous information across the entire shelf so that they can use it in their models to improve the quality of the physics as we understand it. So we're not just putting out receivers, we're putting out receivers that can send information up from the bottom of the sea about various kinds of physical and chemical parameters, and also testing a whole range of different undersea technologies. Perhaps the real core of the Ocean Tracking Network, in the same way as OBIS is the core of the Census of Marine Life, is a website. So this one just shows that we have representation from all over the world. We have partners from all over the world. All of the partners have access to this data set. And we have regulations about how to manage data. All of the data becomes public and accessible to everyone after 2 years. But in the meantime, there are requirements for how you use the data and how you cite the data. Another technology that we've been testing recently off the East Coast is, this is we call it a bioprobe. It's a seal that talks to satellites at one end and listens to other animals acoustically at the other end. And so this merges the two technologies of top and post. And we've actually been tracking these gray seals from Sable Island for a decade. We know where they go, we know what they interact with, and there are many other species that are being tagged in this region. Just want to talk a little bit about this. These are giant bluefin tuna that are being tagged off Prince Edward Island, and they're one of the species that the seals will interact with, also salmon, also cod, a variety of other species. So these tuna are being double tagged so that they have a 1-year satellite tag that will tell us exactly where they are for that year. But then after that year passes, we get acoustic tags on them that will tell us what they do over the next 10 years. And so not only do we get a high-resolution picture of right now, but we get a long-range picture of the changes over the time course of climate change from these animals. The reason that the bluefin tuna are so interesting is that there are 2 breeding grounds, one in the Gulf of Mexico and one in the Mediterranean, but the stocks mix completely during the feeding phase all across the Atlantic. And so we need to have a lot of information to be able to manage this problem effectively. Oops. The Ocean Tracking Network has plans. This year we'll start this line across the Strait of Gibraltar to monitor everything that goes in and out of the Mediterranean, and it will be completed in 2011. We also are working to put a line here at the entrance to the Gulf of Mexico, working with the Caribbean Large Marine Ecosystem Project. This is a little further out in terms of being a reality, but we hope it's going to come to pass. Just following up on Jesse's comments about the oil spill, you all remember this was where the oil spill was. These are the hot spots for tuna breeding. This is where all of the tuna from the East Coast and come to breed, including the ones, the giants from Prince Edward Island. And they came at exactly the right time for the oil spill. And the good news is that as soon as the oil spill came, they all went home again. And they said, "What the hell? We're going to get out of here. We don't need to hang around with this oil." And they came back across the Cabot Strait line. We detected them, and this had good consequences because the fishermen were not really quite sure why we were asking them to take their big valuable tuna and throw them back in the water. But they realized that the data that we provided them actually gave them a basis. They didn't have to kill tuna anymore for money. They could just sue BP for interfering with the breeding grounds for their fish. We're not sure how that's going to work out, but that's what the fishermen are now thinking. The last thing I want to talk about is Atlantic salmon. This was Victor's special request for me. This is a species that has a very complex interlocking life history in the North Atlantic between Europe and North America. The latest paper on this subject is called the merry-go-round hypothesis. Just came out from some of our Ocean Tracking Network people in 2010. And it emphasizes the fact that these animals are actually riding a current system in order to have this complex life history. I'm not going to try and describe all of that to you, but that current system is going to change with global warming. And so understanding exactly how the animals behave is going to become more complicated. We've been tracking Atlantic salmon from the US and Canada, and we can follow them all the way up into the Labrador Sea using the OTN system. We've learned that they all have a relatively repeatable use of a relatively small area, and they also use a relatively small period of time. All of the salmon from all of these rivers are migrating north at the minimum time for the southward flowing Labrador current, so they're smarter than we thought they were. Similarly, inside the Gulf of St. Lawrence, we have a number of different river systems, and we monitor everything that goes in and out here at the Strait of Belle Isle. And again, it turns out that all of these different river system salmon are migrating together across the Strait of Belle Isle over a relatively narrow window. Now, we don't know as much about the current systems here, but it may also be some sort of social interaction that they school together for safety reasons. We're trying to understand it. Now, this is a paper from the Future Marine Animal Populations group at Dalhousie. Ram Myers, which looks at the interaction between cultured salmon and wild salmon. And essentially what this shows is that in every place that increases in salmon culture have come, there have been decreases in the landings of wild salmon. It doesn't really explain why, but it's consistent. Now, Victor particularly asked me to talk about what could we tell Chileans about cultured Atlantic salmon, and this is the longest record of a migration of a tagged cultured Atlantic salmon, an escapee, and it goes from Canadian waters into U.S. waters, so it's another one of those situations where you have the complication of international waters. This is on the west coast, where there's also a large Atlantic salmon culture operation in British Columbia. And we know that the Atlantic salmon have bred here, so they've adapted and been able to breed. This is Vancouver Island, and this is the most remote recapture of an Atlantic salmon. So they do travel large distances, so there's a lot to understand about this process. And this is our colleagues in Australia, and you'll see that they have a very extensive system of lines, like the post lines, that monitor the movements of various kinds of animals that are tagged. A lot of their emphasis is on great white sharks, but they also have some 50,000 escaped Atlantic salmon every year from culture operations. And I've been in communication with one of our partners there in Australia, Jason Simmons, who's actually got a proposal going forward to tag and track the escaped Atlantic salmon. And he's been in contact with some of our Chilean colleagues about the possibility of using this same approach in both countries, in both cases. I just throw this in to show you that the whole oceans are involved in these tracking operations. This is a great white shark that went from Australia to South Africa. And I wanted to remind those of you that are interested in the Chilean salmon escape problems that there are only two places that the salmon can go, really, well, Antarctica and South Africa or Australia. And we've got it all covered. We've got partners there, and they're just waiting for your salmon to show up in their waters. Okay, thank you.